So this is a pretty difficult section. What we're going to be doing is graphing rational functions. And we're going to need all the tools we learned in our last video about horizontal and vertical asymptotes. I'm not going to I wouldn't have you do a slant asymptote here, but you could. And we're going to add some new tools as well in order to help us figure out how to graph something as complicated as this. And one of the new tools we need to find the intercepts. Now this works exactly the same as it always has, all the way back to when you were working with lines. If I want to find the y-intercept, that occurs when x is 0. So I'm just putting 0 into the function everywhere there was an x, and I'm tidying that up, and I find out I get negative 3/5. So I've got the y-intercept is when x is 0, my y turns out to be negative 3/5. Now let's also do the x-intercept. Now don't be overwhelmed. Don't forget this notation here, f of x is just y. So an x-intercept occurs when y is 0. So we just replace f of x with 0. Now what's interesting here is when you're solving an equation like this, the denominator, when it equals 0, the denominator has nothing to do with finding the intercepts. So only the numerator here matters. So when I'm plugging in 0 for y, what I'm saying, and not saying it very well, is if I want to solve this, this has nothing to do with it. I think you could think of it two ways. If I multiplied this entire denominator over to the other side, it would be times 0, so it would be gone. Well, let's just stick with that. There's another thought too, but now, if that denominator has nothing to do with it, I'm just going to set the numerator equal to 0. Solving that using the 0 product property says that my x-intercepts are going to be 2, 0, and negative 3, 0. Okay, now we have one more skill that we're going to use. So they've shown this very complicated graph. I'm going to get started. I've borrowed this one from another textbook. Hope they do not mind. Now I'm going to put all the pieces together and show you one more skill here. So let's first of all find those intercepts that we just learned. So I'm going to find my y-intercept. That occurs when x is 0. So I'm going to put 0 in here, and do you see what's immediately going to happen? I'm going to have 0 over negative 4, so my y-intercept is 0, 0. Now let's find my x-intercept, and you can probably guess what's going to happen here. The x-intercept is when y is 0, so I'm going to have, only the top matters, so I get 0 equals 2x squared. So solving this, and you see that I'm still just going to get 0. Okay, so my y-intercept and x-intercept are the same point. Now let's do our asymptotes as well. So I'm just starting with the horizontal. The horizontal asymptote here is the 2 over the 1 because they have the same degree. So I've got a horizontal line here at 2. Now how about some vertical asymptotes? Well, if I factor this down, I get x minus 2, x plus 2. So I have vertical asymptotes at x equals 2 and x is negative 2. Alright, now we're going to add one more piece to this puzzle. We want to know if our equation here ever crosses that horizontal asymptote. And it's going to be a useful bit of information. So what we're going to do is this. The horizontal asymptote is when y is 2. So I'm going to put 2 in here for y. And I'm going to see if there's a value of x that can make this true. Sometimes there is, and sometimes there isn't. So I'm putting 2 in because that's the horizontal asymptote, and I want to see if there's a value that makes this true. If so, our graph must cross the horizontal asymptote. Remember, you can't ever cross vertical asymptotes, but you will sometimes cross horizontal. So if I send this over to the other side, I'd have 2x squared minus 8. You see what I'm doing? Multiplying this times 2 equals 2x squared. Now, if I try to solve for x, I'm going to get them all back together on the other side. Well, look what's going to happen. They're going to drop out. And I'm going to be left with negative 8 equals 0. Well, that isn't true. So we do not cross our vertical asymptote because this is a lie. It means there's no value of x that makes that happen. Now, we have all this useful information. Let's begin to put it together. So this isn't going to be to scale very well, but I'll do my best. Alright, my y-intercept and my x-intercept are right there in the center. So I'm also going to do my horizontal asymptote here. Is that y is 2. I've got vertical asymptotes at 2 and -2. All right, and I know that I do not cross this line right here. Okay, now here, sometimes we're going to need test points in order to fill in all the blanks because I've only been given one dot here. But it's actually very interesting. We actually have enough, I think. Am I right about this? Yeah, so let's start with this knowledge. We know that we do not cross the horizontal asymptote, and I have this dot right here. So, hold on one second. Let me check something. Okay, I'm back. I had to check on something because I didn't think it was going to work right, but it is going to work. So the first thing we have here in the center is I have only this y-intercept, the x and y-intercept at the origin. So this is what I was confused by. This should have, I thought this would have had to come up with a bounce, like it had multiplicity. So I'm not sure about how that part works here. I thought that was going to be true, but here's what I know. I knew that I didn't cross this horizontal asymptote here. And I know that I only touched at one point. And so I have to stay inside of here. Like the lines will stay inside of these two vertical because they can't cross. And since I don't cross the horizontal, I know this must happen. Now where I was getting lost was I didn't expect a bounce. And if I crossed through there once, there'd be no way for me to come back again. So it's a bounce. And again, I thought back when we learned about multiplicities, we would have seen the multiplicity of 2 here for the bounce, but not sure why that is. But so you can see from the logic of it one more time, you can't cross the horizontal, and we knew we had to touch here. So I know that this line must come here, and it has to touch just once and come back down. It has to bounce because we only have one location where we touch the axis. Now, this is what I've got so far. And sometimes you could use test points. It'll work the same, like pick points in different regions to find out what the graph is doing. But there's a really clever trick here that's going to tell us everything we need. Now, if we factor this down, we had this, x minus 2, x plus 2. Now, when you look at these asymptotes, if they have an exponent of 1, which they do here, then when you reach an asymptote, the line will go on the other side, so what in the other direction. So what I mean is like this graph is going down here. So when I reach -2, this one right here, it has an exponent of 1, which means the line will be going in the other direction on the other side of the asymptote. Are you following me? Because this is a really important tool. So we were going down, so on the other side of the asymptote, we'll be going up. Well, if I know I'm going up, and I know I don't cross the horizontal, I would get that. Now we go over here, and what do we see? Well, once again, as we approach this asymptote, which is this one, the 2, it's a degree of 1. So if this is going down, on the other side it must be going up. I don't cross the horizontal, and I get this picture here. Now again, you could do this with test points, but this is much easier if you can just think through the logic. Now we'll see later one. I think I'll have one in here. Like suppose it had been this. Well, if it has at this asymptote with a degree of 2, in such a case, like let me say if this was a horizontal asymptote, well, it'd actually be over here at 2, then they would go in the same direction as it approached that asymptote. So as it approached this, because of the 2, the lines on both sides would be going in the same direction. Now we'll see that later here, but hopefully that makes sense. Let's do another one of these, go all the way through here. So I'm going to write down all this information. I'm going to do my y-intercept. And so y-intercept occurs when we put a 0 in here. Now I'm not going to plug them all in. Do you see what's going to happen here? Everything's going to drop out except, so when x is 0, I get -8 over 3. Can you buy that? All these guys are going to drop out, -8 over 3. Now let's do my x-intercept. Okay, my x-intercept is when y is 0. So I'm going to have 0. This is the only part that matters. The denominator has nothing to do with it. Now, I'm going to factor this. Now I'm doing the guess and check method here, but you could You could do the AC method, or if you need some help on this, I've got old videos on that. Let's see, it'd be 4 and 2. Okay, so if I solve this, there's a better way to actually factor this. So, you know what, let me pause and show you. So the better way to do it I should have taken out a GCF at the beginning. So you always should do the GCF first. Now, if you have this, it factors down. This is a perfect square trinomial. You'd have x minus 2 squared. Now, if I'm solving for the intercepts, this has nothing to do with it, but my x-intercept is going to be at the point 2, 0. So I'm basically just solving x minus 2 equals 0. Okay? Okay. So I've got my x-intercept. I've got my y-intercept. Let's do our asymptotes. How about horizontal? So the degree of these is the same. So I have a horizontal asymptote at y is 2. How about vertical? Oh yeah, this is a strange one. I've got a vertical asymptote here when x squared equals 3. So x would be plus or minus the square root of 3, which is about plus or minus 1.7. Okay, I know that's strange. So I have asymptotes here at plus or minus 1.7. Okay, let's put all of our, one more thing. I forgot. I want to also know, do I cross my horizontal? So I'm going to put a 2 in for y. And see if I can come up with a value. Now I'm going to swing all of this up to the top, and I get 2x squared minus 6 equals 2x squared minus 8x plus 8. Okay, now if I swung these over to the other side, I'm going to subtract 2x squared from each side. They'll be gone. So now I have negative 6 equals negative x plus 8. Now solving this, I'm going to send him over. Divide both sides by negative 8. And this is taking up all my space. I get 7/4. Okay. So I do cross. So at the point 7, 4, and 2, I cross. So let's see how much, if I have enough information here to graph this. We can always use a test point if we need to. Okay, I'm just randomly picking what I'm going to do. I'm going to do my horizontal asymptote. I'm going to do my vertical asymptotes. So a little less than 2. So I'm doing negative 1.7 and 1.7. Ooh, boy, that wasn't very good. Okay, now I know that I cross 7/4. Yeah, this is at 1.75. So this is actually, it does cross, but it's a little bit over there. So it crosses just past that asymptote. Okay, so it doesn't cross in here. Okay, now our y-intercept is at 0. That would be about negative 2 2/3. So somewhere right about there. My x-intercept, it crosses at 2. Sorry, points are difficult for the pen. Okay, now let's talk through what we have here. I do cross, but I do not cross in this middle region. And so I know that I have to have this, because I have to go through this intercept, and I don't cross the horizontal asymptote, so I must be doing this. Now let's start over here. Look at this trick. So if I factor this down, it's well, it's a little weird to factor that, but I do not have two of the same thing. So I don't have a degree of 2 on 1.7. So yeah, let me do it like this. It would be, here's what this would be factored. This denominator factored would be this. And so I don't have a degree of 2 on that denominator. I have degrees of 1. And my point of this is that if I was going down here as I approach this asymptote, I'm going up here. So I've got this. Now over here, I have the same thing. If I was going down here, then I have to be going up here. Now, I've actually seen a picture of this graph. It does a very weird thing. It goes through here because we said we had to, and then it's going to bounce here and go over here. And I think this bounces, yeah, this bounces like you would have thought it was, which is what I didn't understand on the last one. So we had a multiplicity of 2 on this intercept, and so we see the bounce like we've learned before. Okay, very strange picture, but that's what we'd get. Okay, now I don't know how many more of these I have, but let me do another one here. I would stay away from this one, but let me show you. Let's go through our pieces. If I were giving you one, I wouldn't give you this one. But if I do my y-intercept, that's when the x's are 0. So I'm going to have 2, -3 on the top, 1 times -2 on the bottom. I've just replaced all the zeros. You see, this is all I would have left. So I get -6 over -2, so I get 3. So my y-intercept is the point 0, 3. Now, I'm sorry this is all over the place. I just don't have a lot of space. Let's do the x-intercept. That's going to be just this top. We're going to get x is -2 and x is 3. Okay, so those are the points, -2 and 3. Okay, so I have my x-intercepts and my y-intercepts. Let's do our horizontal asymptote. Now this isn't multiplied out, but if you look at this here, I'm going to have 2 x's on the top and 3 on the bottom. If the degree on the bottom is larger, it's going to be y is 0. Now, how about vertical? So do you see here we have vertical at x is 2, would make this undefined, and also at x is -1. Now notice here it's got this square, so that's going to give us some useful information. Now the reason I would stay away from this one is this one does not allow us to check to see, or it doesn't allow us very easily to check to see if this crosses the horizontal asymptote, which is very valuable information that helps make this work. So I'm going to tell you that this one does not cross. The way you could check that is you'd have to use some different test points to try to see if you could make this work. But I'm just going to tell you that this one doesn't cross, and I would give you ones where you could test it. Okay, so let's see what we've got here. So I've got a horizontal asymptote right there along the y-axis, along the x-axis. I've got vertical at 2 and -1. Okay, let's do our intercepts. I got intercept there. Oh yeah. Yeah. Oh geez. Sorry. So marking my intercepts. Yeah, this is what was weird about it too. It doesn't have it doesn't cross the horizontal here, but the intercepts are actually on top of the horizontal asymptote. So they're like right on top. So it does cross at those 2 points, but it doesn't cross in the middle. Okay, so we have everything we need if we know that we don't cross in the middle. Look what will happen here. We know this because we don't cross, and I've got to touch that point. So, and I can't just be stranded down here. I got to finish. So it'll go up like this. Now let's talk about our knowledge here. Look at -1. This has a square, and because it's a square, I know that it's doing the same thing on the other side of the asymptote, like this. Okay, now we know we touch here, but we have that horizontal asymptote. It basically just goes along this line. So I think it goes, I don't know if it follows under or above. I wouldn't really care if you get this. This is what I know. I know they're the same direction. I touch this, and we've got to approach that asymptote. Now over here, as we get toward 2, that had degree 1. So that one on the other side of the asymptote is doing this. We come here, we know we have to touch this, and then we go down. It might cross all the way over, I don't know. But this would be good enough for me. Oh yeah, here's the actual picture. Yeah, this one does, they both do cross and then they follow, but that's okay. I would be fine with that. And now we weren't exactly precise here in the middle, but that's good enough. We got the idea. That's what I would be grading you on. Okay. Should I do one more of these? Yeah, we'll do one more of these. Okay. So let's find our key ideas. I'm going to do my x-intercept and my y-intercept. So my x-intercepts, let's start with y. Y happens when this is 0. When I put zeros in for x, so I've got 2 squared times negative 2 over 2 times 1 squared. So I just put in, oh, hold on. I'm sorry. I got confused what I was doing. I'm putting 0 in here. So 2 squared minus 2. Okay, if I put 0 in there, this is what I got. So I've got 4 here times negative 2. I've got negative 16 on the top. Negative 1 squared is going to just drop out. That would just be 1. So I've got negative 6 on the bottom. So I've got positive 8 thirds. So my y-intercept is occurring at 8 thirds. How about my x-intercept? Okay, so my x-intercepts are negative 2 and 2. This one has a multiplicity of 2. So it should bounce. Okay. So I've got those. What else do we need? We need let's check for a horizontal asymptote. Now, I'm not going to multiply this all the way out, but do you see I've got 3 x's on the top. I've got 3 x's on the bottom. Now, what's in front of those, if you did multiply them out, there's going to be a 1 in front of here and a 2 on the bottom. I'm going to get a horizontal asymptote at 1/2. Now, how about vertical? Vertical, I'm going to have, you can't have x be 1, and notice it's got its square there, and you can't have x be 3. Okay, so how about crossing? Oh yeah, this is another one where we cannot check to see if it crosses. Yeah, this one might be possible, but with the cubes, I'm not going to ask you to do that. So let's start building it, and I'll tell you what our options would be. So I've got vertical asymptotes here, and y-intercept is 0. Right about there. X-intercepts at 2 and negative 2. Do I have, oh, my horizontal is that y is 1/2, so it's coming right through like that. Okay, so I like to start with this center region, and I believe this does not cross, but let me see. Okay, so here's our key question. This one would tell us whether or not we are crossing, and I don't know if I want to do it the other way. So what I would do here to find out if I'm right is I would do a test point on this side. So I would do a test point of something like 1.5 and a test point of like 2.5 to see if I'm on either side of these lines. Yeah, let me hold on one second. I don't know if I want to do that, but I'm going to check this. Okay, I did some test points and checked on both sides of this intercept right here, and I did 1.5. So when x is 1.5 and I got a negative, and then I did when x is 2.5, so just on this side here, and I also got negative, about the same number, about 0.65. So here's my point. These test points show me that I am not crossing this horizontal asymptote. Now if I'm not crossing, here's what I know. I'm doing this. And now with this information here, I can find everything else that I need, I believe. So let's see. So when I'm approaching this asymptote right here at, what is this one? This is 1. It is the one with the square. So that means that I'm heading in the same direction on the other side of the asymptote. So I'm going here. We know that we cross this guy, but we don't cross there again, so we get this. Now, how about at x minus 3? On the other side of this one, because it's a degree 1, I'm going the other direction. And so I know this. Okay, I know this is difficult, but let me finish with one more here. This is not the type of question I would ask. It's in the book, so let me just show you here. We're going to go ahead and take a look at this picture and turn it into a rational function. So notice here we've got our asymptotes. I've got vertical asymptotes. So I've got one at -1, it appears, and then we're going to call the other one 2. So do you see, basically I have these two lines. So let me see, did they call them the same? Oh, what are they doing? Oh, no, they're not right. Yeah, it's 1 and 2. Okay, so look what they could do. So because we knew we had vertical asymptotes at 1 and 2, we can turn that into x, or -1 and 2. We can turn that into a denominator like this. Now, look what they did here. So looking back here at our picture, when at 2, the arrows were headed in the same direction. So they knew that was a square. You see what I'm saying? So at this asymptote here, they were heading in the same direction. So that's a square. Now, what did we know about the top? So we have our intercepts here at -2 and 3. Oh, that's what they were talking about here. -2 and 3. So those are the solutions, but if we wrote it like in factored form here, we'd have this. Now, we have all the pieces we need, but we always have to check for a stretch factor. And so the stretch factor here, we need a point. The typical point to use is the y-intercept, and that is 0, -3. And so we're going to put in the point, is that -2? Sorry, that's -2. So 0, -2. Putting zeros in for x, we know the y is -2. We can then solve for this stretch, crunch all this down, just do the basic algebra, and we get a is going to be 4/3. So we put that in front of our equation as our stretch factor, and we got it just by reasoning our way through it. Okay, now I know that's quite a bit. This is one of the more challenging sections we've had, but we're just going to go through one piece at a time. You're going to find your x and y intercepts. You're going to find your vertical and horizontal asymptotes, and then typically you're going to be able to check to see if you cross that asymptote. And finally, start with the middle section. If you create one of those middle sections, then start with that section, and you can use the trick about whether the terms on the bottom have a degree of 1 or a degree of 2 to help you reason your way the rest of the way through.